Introducing the MultiTouch Cell, a ready-to-roll multi-touch display that has everything one needs to build multi-touch installations built right in. Each cell contains a full high-definition display, measuring either 32 or 46 inches. We also have a 32-inch HD-ready display, more suitable for flash-based installations. Each cell has everything one needs built right in. Just connect the industry standard HDMI, FireWire, and USB cables into either a Mac, Linux or Windows computer, turn on and go. Handy status lights even indicate when the cables are connected properly. There's no need for setup, no moving parts, no maintenance, just ready to roll displays that can beat power from even a laptop. The cell is also flexible when it comes to installation size. Want a bigger display? Just add another cell. Want to make it bigger than 2 displays? Just add another commodity PC, some Ethernet, and you're ready to build displays at 5, 10 or 20 meters in length. In fact, our Cornerstone SDK allows for display sizes to only be limited by your imagination or your budget. The cells also work at any angle or orientation, so you can build walls, tables or floors. Enough talk, let's see a MultiTouch cell in action. Here we can see 2 cells stacked one on top of another in portrait mode. The displays are running from one single computer. They're running at 60 frames a second. The application you can see is a physics application. This physics application is one of many example applications that comes bundled with the Cornerstone software development kit. The Cornerstone SDK comes bundled with all MultiTouch cells and is used to build multi-touch applications. These multi-touch applications can be built so that they scale across one or several displays automatically. Let's look at how the cell adapts to changes in the environment. Here we have turned off all the lights in the studio, and we have a user interacting with one of the cells. He's simply playing with the physics application. Now, if we turn on the lights, we can see that the cell adapts to the environment automatically with no need for configuration changes. We can see 2 users interacting at the same time. The goal is simply to move the object off to the other side of the display. You can see that all the graphics run at 60 frames a second, and the size of the cells allow for 2 people to interact simultaneously with ease. Let's look at some basic interaction. Here we can see a user drawing a spiral. Every time that she makes contact with the screen, another color is drawn. We can see that she can interact quickly or slowly. The display is able to keep up with all her actions. Let's look at some more complex interaction. The MultiTouch cell sees hands, not points. Other solutions see this, essentially a series of dots not connected to anything. The MultiTouch cell, however, sees this, 2 points of interaction, the left hand and the right hand. By combining these 10 points into the left hand and the right hand, we therefore form 2 unique points of interaction rather than 10 discrete points of interaction. This helps to develop more complex interactions. Let's see a demonstration. Here we can see a user interacting with a cell. Every time she touches, we get a finger with a unique ID attached to her hand. Notice how, even when the hands interlock and become more complicated, the system can identify the 2 hands as discrete objects. Even with multiple users, you will notice that the system still works at 60 frames a second and still does not get confused. Let's talk performance. Let's connect 2 cells to one commodity PC running Linux and do what everyone else does, which is scaling and rotating videos and images. Here we can see 2 users interacting with both cells. They are interacting with 8 videos, all high resolution, running at 60 frames a second. You can see that the interaction is smooth with no latency or lag. This is possible due to the Cornerstone software development kit's focus on performance and scalability. But let's talk performance with a laptop and one cell, something we can all understand. Here we have a fairly stock configuration MacBook Pro, a 2.2 GHz Core 2 Duo with 2 GB of RAM. We have an application rendering graphics at 60 frames a second and doing all the normal hand tracking that's needed. We can see
that we can interact with the display quite nicely, quite quickly, and draw graphics, and still the CPU only hovers between 50 and 60% of use. Let's look at setup and calibration. Once you have your unit plugged into the computer, there is a need sometimes to do visual calibration. Let's have a look. For example, here when we place our hands on the display, we can see that the tracking is a little off by a few pixels here and there. So, to fix this, we have a very simple calibration utility. We simply press a key on the keyboard to bring the application up, and then we simply touch in each of the 4 corners, just like this. Once we've pressed in all 4 of the corners, the calibration will automatically do its thing, and now we can see that the computer vision understands exactly where the hand is and it's perfectly calibrated. Simple and neat. But let's look at environmental issues such as lighting. Other competing systems require continuous setup every day. Ours has auto adjustment. As we can see here, if we untweak the settings, the computer vision doesn't really work, nothing really happens. So we simply hit the auto adjust button and the computer works out exactly what it should do all by itself. And now the computer vision works as it should. Very simple. This is a completely automated process and never really needs to be done again. The settings can be saved to different profiles, just in case.
Introducing the MultiTouch Cell, ready-to-roll multi-touch displays, available immediately from www.multitouch.fi.